All right, an introduction to slope, or the slope of a linear equation, which the most famous linear equation is going to be x plus b, and there's our slope, dm. So just an introduction to slope. There's our coordinate axis system, the x and the y axis. A lot of times in class we'll talk about, hey, let's sneak over to the tree house, leave the world behind, let's stash some food, and we'll just stay there for days. So this time we're stashing Snickers bars, okay, because not going anywhere for a while. We're going to stay there for a few days. We're going to stash away our Snickers bars. But it's nice to look at a graph where the x has meaning and the y has meaning. So after a certain number of days goes by, how many Snickers bars will we have left after we start eating them? So explain this in the context of the problem. Explain all those 6 ordered pairs, those points, in the context of this graph. Well, let's go to this guy. The first coordinate is x, second one's y. That's 0 days and 60 Snickers bars left. That means we're starting out at time 0 with 60 Snickers bars. This point, after 2 days, we are down to 50 Snickers bars. After 7 days, we're down to 25 Snickers bars. So all those points have 2 key pieces of information, and it's nice, instead of just plotting points with no context, to be able to put something in context like this. That's why we go to the treehouse so much. All right, let's see. Oh, plotting these points, one of the reasons we say that there's a linear relationship between all these points is because when we plot them, they all fall on a straight line. Notice, by the way, this guy's pretty important. Y is 0 means there's no Snickers bars left. So after 12 days, we done ate up all Snickers bars. There's none left. That's called the x-intercept. This is the y-intercept, how many Snickers bars at time 0. We have 2 extra points. These are kind of weird. A lot of times they don't mean much for us. We're in the first quadrant with meaningful points. Once we leave the first quadrant, it's like, okay, what does this mean? After 15 days, we have negative 15 Snickers bars. Not sure exactly what that implies. So usually we just restrain and constrain ourselves to just the first quadrant. All right, now here's a slope formula. You've seen this before. All this means is pick 2 points and say that one point is point number 1 and the other point is point number 2, and then use this formula. If this is point 1 and this is point 2, then this is x2 and y2. I'll have students write it down a lot of times. So in the formula, we start here. The slope is y2, that's our second y, that's 50. So we're going to say, okay, slope is the second y, which is 50, minus the y of the first point. We're calling this the first point, so it's minus the 60, divided by the second x, that's the 2, and the first x of 0, so it's 2 minus 0. Now, when we do this math, 50 minus 60 is negative 10. Negative 10 divided by 2. Now, this has meaning. Slope is a rate of change. We will lose 10 Snickers bars for every 2 days we go into the future. So we're going to eat, on average, 10 Snickers bars per 2 days. Hey, let's divide that out. Let's divide by the number 1 so that we can simplify this. And this slope becomes negative 5 over 1. This is the preferred simple way that we would write the slope, either this way or just as negative 5. But I'd love it if we realize that this is a rate of change. That's what slope is. In calculus, slopes are a rate of change big time. We focus on rates of change in advanced math and in the real world over and over and over. So that becomes more common than even referring to this as the slope long term. So we are losing on average 5 Snicker bars per every day that goes by. We're eating 5 Snicker bars a day. That's all it means. Now, we can get the same slope by stipulating a different set of 2 points as being point number 1 and point number 2. So now if we call this point number 2, but this is point number 1, now what's going to happen in regards to slope? Well, if we take the second y, we're saying that's the 50, minus the y of the first point, which is the 25, and we divide that by the second x, which is the 2, minus the first x, the x of the first point, which is the 7, then what do we get? 50 minus 25 is 25. 25 divided by negative 5. We're going to eat 25 Snickers bars for we'll have an additional 25 Snickers bars if we go back in time 5 days. That's what that would mean. But we usually like to put the negative in the numerator. So in the end, this would also simplify. If we divide top and bottom by 5, we're going to get a negative 5 over 1. we usually put the negative in the numerator. So once again, we're saying that on average, we're losing 5 Snickers bars per day. Now there's at least 4 different ways to calculate slope. One of them, just go to the graph. Pick out a couple points right here. We can say, well, you know what? At this point to this point, what happens? Well, we drop down 10, so we're going minus 10 in the y direction, and then we're going up 2 as we go in the x direction. So the slope would be, we lost 10 Snickers bars in 2 days. So there you go, that's the same as the slope we got before. We can use the formula, cha-ching, that's a second way to get the slope. Or, I'd rather we just did it solid understanding. If I look at a bunch of points like this, I say to myself, at time 0 we had 60 Snickers bars, after 2 days we had 50. I see that x is going up by 2 and y is going down by 10. I know there's a negative relationship, but that's how I can get my slope. That's what I'll do, quite honestly. I won't take the time to write down y2 minus y1. I just kind of look at it right here. Same thing, going up by 5, going down by 25. So I say, oh, y is going down by 25, x is going up by 5. So I simplify that to negative 5 over 1. Then another way would be we could use a table, a t-table. You've seen this a lot. And then you might just add a couple columns. This symbol is the change in the x, and this is the change in the y. It's a delta symbol. It's a lowercase Greek letter, and that implies change. How are things changing? So look at this. When we went from this point to this point, this ordered pair, after 0 days, there's 60 Snickers bars left, to after 2 days, there's only 50 left. Our change in x, we went up by 2. Change in x is 2. But the change in y, we dropped down by 10. So this is minus 10. We've dropped down by 10. Hey, what's that over there? Yeah, I gotta change this guy. That's supposed to be a 25, sorry. Okay, oh look, there's a negative 25. All right, so anyways, we'll go back to this. This point right here, we're going up by 5, and we're going down by 25. So, the change in the x is 5, and the change in the y is, we're dropping by negative 25. So if we go over to this column over here, let's go blue, and we say, okay, the slope is the change in y over the change in x, then we take any of these points, we're saying like right here, our change in y over our change in x was negative 25 over 5. That simplifies to the negative 5 over 1. This guy, negative 25 over 5, that's negative 5 over 1. Negative 15 over 3. If we do, the change in y was negative 15, well the change in x was 3, because when we went from this point to this point, x went up by 3 days, and y dropped by 15, so we lost 15 in the y direction, change in y over change in x. All these change in y's over change in x's between any of these ordered pairs are all consistent. They keep simplifying to a rate of change, a slope of negative 5 over 1. Now we say that this is a linear relationship because there's a constant rate of change. We're dropping at a steady 5 Snickers bars per day, 5 Snickers bars per day as we go down, and all these points will be in a straight line. So you have a linear relationship when you have a constant rate of change, a constant slope, and in this case it would be a negative slope. And that's another thing I'd like to mention right while I'm here. If you look at this, when x is going up by 2, y is going down by 10, so it's a negative slope. Y is going negative while x is going positive. So as the x's get bigger, the y's are getting smaller. That's a negative slope or a negative linear relationship. And let's just finish up with this panel right here. What we have, this would be a positive linear relationship. Constant rate of change, all the points are in a straight line, but as we go up in days, the number of Snickers bars increases by a steady amount. So we start out with a certain amount, and then we're gaining Snickers bars every day. I don't know why, but we're like squirrels hoarding nuts. Over here, no matter what day we're on, the number of Snickers bars is staying at 30. So this is a constant rate of change. There's no change, but we would actually say there is no slope. The slope is 0. After all, if you picked any 2 points, like let's say these 2 guys, if you do the slope here, do the second y minus the first y, that's 0, divided by the second x minus the first x, that's 5. 0 divided by any number is still 0. The slope is 0 when you have a horizontal line. Lastly, look at this bad boy right here. Pretend that's perfectly vertical, all right? These points in a perfectly vertical line, but think about what that implies. After 4 days, 50 Snickers bars. After 4 days, 30 Snickers bars. After 4 days, we have 10 Snickers bars. That doesn't make sense. We say that this is undefined. This vertical line has a slope that's undefined because it doesn't make sense. We're not defining this relationship appropriately. And the other way to think about that, and the last way I'll leave you with, is right here. If you try to calculate this slope, look what happens. Let's take any 2 points. Take these two guys. The change in y, there's the second y minus the first y. So that's 30 minus 50 divided by the second x minus the first x. That's 4 minus 4. Ha! Look what happens. We get negative 20 over 0. In math, whenever we divide by 0, you can't take any fixed number of zeros out of negative 20. It doesn't work. Dividing by 0 is undefined. Slope is undefined. Slope is undefined because it makes no sense to have all these combinations of days and Snicker bars. So, positive slope, slope of 0, and undefined. There you go. There's an introduction to slope, and we're going to be working with it a lot more the rest of this class.